Welcome to Math is Fun with Amajoy. Welcome to today's lesson. So for today we'll be doing fractions. So this is just a build up on all what we've done previously. So yeah, I'll be introducing you to the rules of adding and subtracting fractions. So we'll be talking about fractions that have the same denominators, fractions that have different denominators. So we'll be finding how to solve problems with those. So first of all, let's see what a numerator is and what a denominator is. So if I have fraction, a over b, a is known as the numerator and b is known as the denominator. So it is very, very important that you know these names, because in your adding or subtracting anywhere, you would need to refer to this name. So the top one is the numerator and the down one is the denominator. Okay. So I'll be using this alphabet to explain the rules. So now let's take the first rule. So rule 1, adding fractions with the same denominator. So with this, I'll use alphabet to bring an example. So when we have the same denominator, so it can be in the form of a over b plus c over b. So this is one of the easiest questions you can get in fractions. So why am I using alphabet? Yeah, it's very, very easy understanding it with abstract, then applying it to any question you've been given. So in this case, I've been given a over b, c over b. It can be any number. So you understanding this principle of alphabet will help you solve any problem you come across. So now this is the numerator, different numerators. That is really not necessary. Our main focus is usually on the denominators. So you can see this b here and this b here. So it means we are having the same denominator. So this can be a question of, let's say, 3 over 2 plus 4 over 2. So this, it can take the form of this because they have the same denominators. So when you have a question like this rule should come into your mind. So now when we have a rule like this, what do we do? So in a case like this, what we have to do is to just maintain one of the b's. So normally I tell my students to take the prettiest b, the b that looks very, very nice. You pick that. So I'll pick this. Just pick any b that I think it's nice. So you pick the nicest one of it. So I say that so you can remember that you need just one of them. You don't need a two. Only one. Don't add them. This is rule 1. So when that happens, we've gotten a denominator. As I said, our main focus is on the denominator. So you just have to go ahead and then add the numerator. So the numerator doesn't have any binding rules, only the denominators. Fine. So when this happens, this is what we get. So a plus c over b, one of the b's. We chose the nicest b. Now let's apply that to our question of 3 over 2 plus 4 over 2. So we said we maintain one of the b's. So we pick the nicest 2. So I'll pick this 2, or you can pick those 2. So I've picked this 2. Then you just add the numerators. So 3 plus 4 will give us 7 over 2. That is all you need to do. The same thing applies to subtraction. So for instance, if I have a question of, say, 3 over 6 plus 1 over 6. Just remember rule 1. Rule 1 says if the denominators are the same, maintain one of the 6, the nicest 6, and then add the numerators. So this can be added. We have 3 plus 1 is 4 over 6. Yeah, I forgot. I wanted to use this example for subtraction. Okay, so let's get that for subtraction. The same principle. So addition and subtraction, they work hand in hand. So don't conflict the principles for addition and subtraction with multiplication and division. So the rule that applies to addition and subtraction does not apply to multiplication and division. So that is a whole different thing on its own. So let's see for the subtraction. Since we have the same rule for it, if we have a question of 4 over 5 minus 3 over 2. Sorry, 3 over 5. So 4 over 5 minus 3 over 5. Denominators are the same. Maintain one of the 5. I'm maintaining one. I like the one that I've painted really bad. So I've picked that. I've maintained the 5 that I have shaded really bad. Then I subtract the numerators. So this is 4 minus 3, which is equal to 1 over 5. Let's take another example. So I hope you have your book and your pens to be writing out this example. So you can pause the video, work it on your own, and then play it to see if your answer is correct. So let's get another one. 8 over 4 minus 2 over 4. The rule says take the nicest denominator, because the denominators are the same. Take the nicest one of them, then subtract the sorry, I'm used to exponents, so subtract the numerators. So we have 8 minus 2, which will give us 6 over 4. Yeah, so I know some of you are familiar with the cancelling feather. So for now, let's just limit it to leaving your answer like this. So probably there will be another video on how we do this cancellation, which is equivalent fractions. So you can try to read ahead before the class of the equivalent fractions. Okay. So I hope you got this rule 1 right. This rule that says we should maintain one of the denominators, maintain one of them, and then add the numerators. Okay, so I'll be leaving an exercise for you in Google Classroom for you to try your hands on it. So I hope by the end of this video you would be able to add and subtract fractions of different forms. So let's see another one. Okay, so now let's take another rule. So if you didn't understand what I said, you can go back to replay the video or just send me a private comment and I'll explain it to you again. So let's move forward to the second rule. Rule 2. So rule 2, I like to call it rule 2A because I have personally, I have two ways I can solve this, but I know some of you have different methods. Today in class, I saw a different method which I have not seen before, which I'm yet to confirm, which might be correct. I really don't know. So me, I don't like to limit myself or limit my students to one particular method. There are so many methods to solve a particular mathematical problem. So let's see this rule 2a. So rule 2a is when the denominators are not the same. So now this is a different thing. So when the denominators are not the same, so let me just make this rule 2, then I'll break it down. So a, when the denominators are not the same, rule a, this is what you can do. So in this case, now we have, let's say rule 1, the rule I, so that we don't get confused here. So rule I, the dot has refused to come. I want to dot my I right now. It's refusing to come. Just come as a candle. Okay. So for rule 1, rule I under the rule 2, when the denominators are not the same. So in this case, if we have a question of A over B plus C over D. Now we have different denominators. As I said early on, we choosing a particular rule depends on only the denominator. We don't look at the numerator. So the numerator doesn't tell us which method we should choose. Only the denominator. So in this case, when we have different denominators, what we can do in rule I is to find the LCM, and the LCM is we multiplying this by this. That is for rule I. Rule I's method of finding the LCM is by multiplying the B by the D. It's actually not the LCM, but finding a common denominator for them. So in this case, we are not really looking at the LCM. Yes, for the record, we are looking for a common denominator for these two fractions. Okay, I didn't say this earlier on, but I can just chip it in now. When we say a fraction is any number in the form of A over B. Probably I said it and it just skipped my mind. Okay, yeah. So I think I said it. Okay, so A over B plus C over D when the denominators are not the same. So as I said, we multiply this by this to get B times D. So this is how we can get a common denominator for it. Now let me move us to the next page. So we said if we have A over B plus C over D. Oh my D, Lord. My D is just like a shoe. What? Okay. So I said we multiply this by this, the denominators, to give us a common denominator. So that would be like B times D. Oh my shoe. This is BD. I think I got it wrong now. So B times D is BD. So I don't need that BD now. So my common denominator is B times D. Okay. So what we do next, so this is the first step. So the first step, I think you should write this down in your book. Step 1 Find a common denominator. I'll just leave you to write that. I'll inspect your note. Yeah. Find a common denominator. Step 1. Now step 2, if you found a common denominator, what you have to do is to after you find a common denominator, what you have to do is to ask yourself, this alphabet B or any number that is in this place, how many times will it go into this whole thing? So now you don't need to start. Why I like this method is I don't need to start reciting my multiplication table, because I'll just say, fine, if we said this is B times D, I'm asking myself how many times B will come into this 2. That is B times. It's like B will come and take its partner B, and then they travel. So when B comes for this B, what are we left with? We are left with D. So B will go into B times D, D times. So this D comes to multiply this A that was here before. So we get a D times A plus the same thing. This D that was here, this my shoe, will go into B times this D, which is my shoe. How many times? So this shoe is going to come and take this shoe, of course. Now they will have the same shoe. So 2, that is a pair of shoe. What will be left? If this shoe comes for this shoe, what will be left? This B. Don't tell me because you've taken this B for this before, so it's gone. Nothing is left. Something is left. It's mathematics. So we will be left with this B. If we are left with this B is going to multiply this C. So it's like a crisscross movement. This comes for its partner and it's left with this, and this has to multiply this. This comes for its partner this, and it's left with this. So this has to multiply this. So would have B times this C that was there. Okay. So if you don't even get it, look at how the alphabet have been arranged. So you can use the alphabet, try rewriting it in your book. Make sure you get DA plus, oh, make sure you get DA plus BC over BD. So you see how the alphabets have intertwined, or yeah, how they've moved. So this BD, this D has come to me the A, this B has come to me the C. So now let's take an example for you to see a clearer view of it. So for instance, if I have 2 over 3 plus 4 over 5, well, of course, I said the first step is for us to multiply the denominators. So we get 3 times 5. After doing so, we would ask ourselves, this 3 goes into 3 times 5, 3 times. What are we left with? So 3 goes into 3 times 5, 3 times. So we are left with 5. So this 5 goes into, this 5 will come and multiply the 2. So we'll get 2 times 5, or 5 times 2 any, plus this 5 goes into 3 times 5. So we are starting it afresh. This 5 goes into 3 times 5 how many times? 5 times. We are left with 3. So we'll be having 3 times 4. Now on the other hand, On the other hand, so let me finish this. So 2 times 5 is 10 plus 12. 3 times 5 is 15, which will give me 22 over 15. Very good. Now let's do this. If I find a common denominator for it, 3 times 5 is 15 already. So some of you can prefer to go the long method. So 3 goes into 15 how many times in your times table? 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 4, 12, 3, 5, 15. So 3 goes into 15 5 times. So 5 times 2 plus 5 goes into 15 how many times? 5, 1, 5, 5, 2, 10, 5, 3, 15. So 3 times. So that is 3 times 4. 5 times 2 is 10. 3 times 4 is 12 over 15. 10 plus 12 is equal to 22 over 15. So we get the same answer. So tell me, if you had 2 over 70 plus 4 over 33, are you now going to start reciting your times table? No. So this method is going to help you solve very, very big numbers. Okay, let's take another example. So not forgetting, I can't find my pen too. Oh, technology. Okay, so apparently my tool has frozen. It's actually here. Oh, okay. Okay, so sorry about that. Not forgetting the rule. We said A over B plus C over D. So we multiply the denominators. Let me use different colors. I think some of you really like colors, so hopefully that will help. So B times, let me make the D blue. Oh. Make the D green. So this will be, then we said this B will going to be the D times. So we'll have A times, A is blue. So this A was there before, times D is green, plus, for multiplication you can intertwine it. So you can bring D first or A first because it is multiplication. So we don't have a problem with that. Plus, so D will going to be D how many times? D times B times. So this B is going to multiply the C. So we'll be having, the B is red, B times C. So this gives us AD plus BC over over BD. Oh, colors. Jeez. Why do I keep drawing a shoe for a D? Okay, we'll take it like that. So you see how the colors have been moved. So AD plus BC over BD. So we see how we've distributed it. Okay. Okay, so let's take an example of 4 over 3 plus 2 over plus 2 over 6. So with this, we said we should multiply the denominators. So we get 3 times 6. 3 goes into 3 times 6. How many times? 6 times. So we'll have 4, or anyone, 6 times 4. Plus 6 goes into 3 times 6. How many times? So 6 will take 6. Let's do 3. So we'll be having 2 times the 3 that is left here. Yeah. When this came for this, 6 was left here. When this comes for this is left here. So 6 times 4 is 24. 2 times 3 is 6. Over 6 times 3 is 18. This is equal to 30 over 18. Yeah. So that's it. So that's it for rule 2. Rule 2I, where we just multiply the denominators. Let's go to rule 2II. When the denominators are different, yes, still different, but now it's a different method. So this method applies to common multiples. So this is where we use the term LCM. So if I have, so let me take the same example, 4 over 3 plus 2 over 6. So this method comes in handy when you know your multiplication table very, very well. If not, you won't see where the clue lies. You won't just see it. If you don't know there is a 6 in a 3 times table, you won't be able to do this. So this is rule 2I. Rule 2I. So the second aspect of rule 2, when the denominators are different. So what you do is to take the LCM. So why do we call it LCM? The LCM here is 6, least common multiple. So someone will say, but 3 is the lowest number here. I know who will say that. But 3 is the lowest number here. Now let's go back to our multiples and see why 6 is the LCM. So multiples of 3 are 3, 6, 9, 12, and so on. Multiples of 6 are 6, 12, 18, 24, and so on. So now what is common here? What are the common multiples? We have 6. So common multiples. We have 6. We have 12, and so on. So what is the LCM now? The LCM here is 6. So in this case, we don't choose 3. We choose 6 as our LCM. Then you ask yourself, this 3 will go into 6 how many times? 3 goes into 6 2 times. 3, 1, 3, 3, 2, 6. We've done factors before, and to find the factors, we have to get the multiplication fact. So we have multiplication fact of, let me wipe this off. We've done multiplication facts where we said multiplication fact for 6. We have 1 times 6 will give us 6. 2 times 3 will give us 6. So these are the multiplication facts. And that is where, in every Zoom meeting during the time we're doing this, I always ask you what is 1 called and what is 6 called. So 1 is a factor, 6 is a factor. This 6 here, the answer we get here is the multiple or the product. This 2 here is a factor, this is a factor, and this is the multiple or the product. So we said 3 will go into 6 how many times? So 3 times what will give you 6? That is 2. That is the other factor of 6. So which other factor of 6 will give us 6 when we multiply by 3? So that is 2. So 3 will go into 6 how many times? 2 times. So we'll take the 2 and multiply it by the 4 that is already there. So times 4 plus, we'll do the same thing here. This 6 goes into the 6 how many times? 6 goes into 6 how many times? 1 time. So we'll use the 1 to multiply the 2 that was already there. So now we can do our multiplication. 2 times 4 is 8. 2 times 1 is 2 over 6. That is 10 over 6. So it's a bit rough. So try and solve it very, very nicely in your book. Okay. Let's take another example. So 4 over 5 plus 2 over 10. So this is very, very easy to spot. You don't need to use the rule 2i. You can use the rule 2i of finding the LCM, and the LCM here is 10. Not 5, because 10 times nothing will give us 5. 5 is not a multiple of 10, but it's a factor. We need a multiple. So after this, we'll ask ourselves, 5 goes into 10 how many times? 2, because 5 times 2 is 10. Don't forget the game we played on multiplication fact. So 5 goes into 10 2 times. So 2 times 4 plus 10 goes into 10 how many times? 1. So 1 times 2. So this gives us 2 times 4 is 8 plus 2 over 10, which is equal to 10 over 10, which is equal to 1. The same number over the same number is equal to 1. A over A is equal to 1. U over U is equal to 1. Okay. So that's the explanation for root. Now let's see something else. So if we have a question of, say, let's get a question. 4 over 12 so 8 over 28 minus 3 over 7. As we said, finding the LCM. So this is all you can, you know from your multiplication table that 7 1 7, 7 2 14, 7 3 21, 7 4 28. So our LCM here can be 28. We know that. If you don't know that, meaning you would have to use the long process of the rule 2i, of you multiplying this by this and then getting 28 times 7, and that is a whooping long process. So this is just easy when you know your multiplication table and you're able to spot factors and multiples instantly. If not, you will waste much time trying to start reciting your timetable, which would take your time during the examination. So 28 goes into 28 how many times? 1. So 1 times 8, 28. Minus 7 goes into 28 how many times? 4. That is 4 times 3. This gives us 8. 1 is 8 minus 12 over 28. So fourth graders, please don't tell me it can't be. This is integer. So 8 minus 12. I'm having 8 CDs and I'm going to buy something which is worth 12 CDs. I am going to owe that person 4 CDs over 28. Okay. So I'll leave more examples for you in the Google Classroom. So after watching this video, try your hands on them and then submit it. I hope you would understand it very well. Okay, so to our next class, there is one more method we will need to know, but I don't want to get you confused. So we'll do that method when we have another live session, or maybe I'll pre-record a video for you. So just digest this one, understand it very well, replay the video several times so you get the concept. Be hungry to solve more questions and keep practicing, and practicing. Bye bye.